Okay, so a plank AB has a mass 24 kg and length 4.8 meters. A load of mass 15 kg is attached to the plank at point C. At point C, we have how much? 15 kg. 15 kg means 15 G. Where AC is given as 1.4. Loaded plank is held in equilibrium with AB horizontal by two vertical ropes, one attached at A and the other attached at B, shown in the diagram. The plank is modeled as a uniform rod. Okay, so this time the plank is uniform rod. So if it is uniform rod, then the point will be midpoint, no? All the weight will act at the midpoint. The load as a particle and the ropes as light inextensible strings. So because these are strings, the tensions will be acting in the upward direction at both A and B. Find the tensions in the rope attached at B. Tension in the rope attached at B. So first bit, we have to find the value of TB. Ready?
Yes.
So I think we can directly go with moments. So take moments about point A. TA will cancel out. 15G times 1.4. This is clockwise, so minus 24G times distance 4.8, because this is at the center midpoint, because this is a uniform rod, and this is again clockwise, so minus. Then TB times total length 4.8. This one is anti-clockwise, so plus. Total should be 0. So TB is the only unknown here. Find the value of TB. That's it. So 15 G value I'll keep it as it is, except for G I will take all the other values. Okay?
Yes.
So both terms positive sent to the other side. So this we will get here. Then so 4.8 TB, we will get this as 78.6 times G. So this implies that TB value will be this divided by 4.8. So 16.375 times G. Okay, and G value we know, G value is 9.81. This is the acceleration due to gravity. Plank is now modeled as uniform rod. Acha, now the plank is modeled as non-uniform rod. Initially we took it as uniform, so it was at the midpoint. Now for B bit, we have to take it as non-uniform. With the new model, the tension in the rope attached at A. So now for the new part, so this one was B bit. Sorry, this one is A bit. For B bit, so tension TA is given. Tension TA is 25 newtons greater than the tension at B. So 25 greater than tension at B. Okay. So this is the additional information given for B bit. Now for B bit, M will not be the midpoint. M will be some other distance. Okay.
Yes.
So this distance, let us take it as X. Now X value we don't know for B bit. For A bit, because it was uniform, we got it midpoint. X was half of 4.8. Now it won't be the so. So he's asking the distance of center of mass from A. So we have to find the value of X. Now here, let's take sigma V. We have to take sigma V in order to find A and B both. So TA is upwards, TB is upwards, 15G is downwards, for 24G is also downwards. So this total should be 0. And we also know the relation between TA and TB. Let us substitute that as well. So 25 plus TB. This is in place of TA. This TB as it is. This total becomes how much? 39, no? 39G on the other side.
Yes.
So now 2TB equals 39G minus 25. So TB value we can find now. Okay. So 39 into 9.881. Yeah, yes, right. 39 into 9.81 minus 25 divided by 2. 178.79 or 178.80 newtons. This is in newtons. Okay. So TB value we got it. Then TA value will be 25 plus TB. So we get how much? Plus 25, 203.8.
Yes.
So TA, TB, both values we got. Now we are interested in finding the length x. So for finding the length x, we have to take sigma m. About which point? Let's take about A only. So take all the values from the one. So 15G, distance is same, right? 1.4. Because that distance is given, it doesn't depend on whether rod is uniform or not. That remains same. This is clockwise, so minus. But 24G, it will not remain at same at midpoint. It will not remain at midpoint. This distance will be x. And this is going in clockwise direction, so minus again, and plus TB times 4.8 in anti-clockwise direction, so it is positive. Okay, so this total should be equal to 0. Now we know the value of TB, we can substitute. G also I think we have to substitute, because G will not get cancelled anyway. So yes, so 24GX equals TB value 178.8 into 4.8 minus 15 into 9.81 into 1.4. So X value we will get by dividing right side with this term. Let's do that. In numerator, 178.8 into 4.8 minus 15 into 9.81 into 1.4. Denominator, we will get 24 times 9.81. So 2.77. All distances are given in meters, so this will also be in meters. This is answer for B bit.